All right, so we're in section 8.7. So for all of the things that we talk about today, the book calls them special cases. We do not have to think of them as anything different from what we've been doing before. We'll maybe notice some helpful things about these particular polynomials that we factor, but we're still using the same process, the same techniques, the cross, the box, the slip and slide that we've been using for the last several days. So I just want to go through some examples. So we want to factor. All of these we are factoring. X squared.
If for some reason I'm not back at lunch, I have some things for me to change the addresses. They're just laying in the on the table in my room.
Okay.
Thanks. I'll text you if I'm gonna.
All right. X squared minus 4x plus 4. So before we start factoring, I just want to point out something about this polynomial. This first term is a perfect square. That means it's something squared. And this last term is also a perfect square, because 4 is 2 squared. So I'm pointing that out because that's part of what makes this a special case. Well, let's go through our process of factoring this. So this is A is 1, B is negative 4, and C is 4. So let's set up our cross. We want two numbers that multiply to 4, since A is 1. And we want them to add to negative 4. So the only way we can get two numbers to multiply to something positive and add to something negative is if both of them are negative. Negative times a negative gives us a positive, and a negative minus a negative is going to give us a negative here. So we need two numbers that multiply to positive 4 and add to negative 4. Hopefully we can see what those two numbers are without using our factor sheet. Yeah. Negative 2 and negative 2. This is 2 squared, and both of those numbers turn out to be 2. So because A is 1, now I can just set up my parentheses. We could say this is x minus 2 times x minus 2. And x minus 2 times x minus 2 is x minus 2 squared. And this is what we're squaring here, and the 2 is what we're squaring here, and the negative is because this is negative. And if we like to use the box, we could set up our box here for this one, just for those of us who like to use the box. This is x squared, this is 4, factor times x, factor times x. Then we pull out our greatest common factors. Biggest number that goes into 2 and 4 is 2, and this is negative. Smallest x that's in both of these is x. Same thing here. And biggest number that goes into 2 and 4 is 2, and this is negative, so we put a negative there. And that's how we get our x minus 2 times x minus 2, which is x minus 2 squared. Yes?
On the test, will show how you work, be like reducing it to x minus 2 to the second power?
No, I'm not that picky about this. But going the other way, if it said multiply this out, we would need to remember, like if we wanted to multiply, if it said simplify this, we need to remember that x minus 2 means x minus 2 squared means x minus 2 times x minus 2, and then we FOIL that.
Right, but if we're doing it like
If you're doing this and you wrote this as your answer, I would be okay with that. Yeah. All right, so let's look at another one. we're still factoring 9x squared plus 24x plus 16. And I'm going to point out here, when we're starting, 9x squared is 3x quantity squared. And 16 is 4 squared. So each of these is a square again. Well, now we have a leading coefficient, so we have a little more work to do. There's A, B, and C. A times C is 9 times 16, which is 144. And 144 is 12 squared. So we have these things that are perfect squares all over the place here. Well, let's set up our cross for this problem. We want two things that multiply to 144 and add to 24. And since this is positive and this is positive, we need them both to be positive. Well, the problem has already helped us out here. What are two numbers that multiply to 144 that add to 24? How about 12? 12 and 12. So now we set up our box. And we have 9x squared and 16. And our factors here, 12x, 12x. Now we pull out our greatest common factors. The biggest number that goes into both 12 and 16. 4. The biggest number that goes into both 9 and 12. 3. And we have the smallest x that's in each of these is 1x. We just did the 9 and the 12. That's a 3. Each of these has an x in there. And we did the 12 and 16 here. So that's 4. So we get 3x plus 4 times 3x plus 4, which we can write as 3x plus 4 squared. There's the 3x and the 4 that came from here. And this is plus, so that ends up as a plus. And that little pattern is going to happen anytime we have a polynomial that's set up this way. So you could use that as a little shortcut to help factor this, but you can always factor the way we've been factoring. Let's do the slip and slide method on this one also. So we have 9x squared plus 24x plus 16. We slip that 9 over there and multiply. So we get, what we're going to factor is x squared plus 24x plus 9 times 16 we said is 144. The cross we set up here is the same for these two problems. So we would factor this as x plus 12 times x plus 12. And we multiplied by 9, so we need to divide by 9 before we finish. 12 over 9, we can reduce that fraction. Well, we said here the biggest number that goes into 12 and 9 is 3, so we divide everything by 3. X plus 4/3 when I reduce 12 ninths. And now I'm going to slide the 3's over. 3x plus 4 times 3x plus 4, which is 3x plus 4 squared, if we use a slip and slides. So when we have a polynomial where the first part is a perfect square and the second part is a perfect square, often they will factor, very often they will factor like this. So that can help you out here. Or you can use these numbers to help you when you're looking for your factors, when you're pulling out your greatest common factors, that kind of thing. Our book calls this, and you'll see this when we have a situation like this, is a perfect square trinomial. So that's one of the special cases that the book talks about, perfect square trinomial. But we can always factor these just like we've been practicing for 3 or 4 days now. Actually, almost a week now. All right, so questions about this process? It's really nothing different. We just have this nice little pattern that we can use if it's helpful. All right, the next special case is sometimes we will have a polynomial with only 2 terms that we need to factor. X squared minus 64, for example. Well, I want to point out here that both of these are perfect squares in this case. This is x squared and this is 8 squared. Well, we're going to factor it first. We're going to factor it like we've always been factoring. I'm going to say this is x squared. How many x's do we have here? No. What's our term with x? What would be our b here? If this is a, I don't have anything with b to go with b here. So what is our number in front of x if we don't have any here? Well, how many x's do we have? None. We have 0. So we can write this as x squared plus 0x minus 64. So when we don't have that term there, we can think of it as 0. So a is 1, b is 0, and oops, it's a b, and c is negative 64. So when we set up our cross, we're looking for 2 numbers that multiply to negative 64 and add to 0. And the only way that we can get a negative number when we multiply 2 numbers together is for one of them to be positive and one of them to be negative. So what 2 numbers are going to multiply to negative 64 and add to 0? How about 8? So this is going to give us x plus 8 times x minus 8. And x came from here, and the 8 came from here. All right, let's look at one more example. 9x squared minus 25. Now when we have a leading coefficient, we should always check. I should have checked on the last problem also. Is there a number that goes into, that will go into both 9 and 25? Does 25 go evenly into 3? No. So there's no GCF. So we don't have to worry about factoring that out. I'm going to say this is 9x squared plus 0x minus 25. And I'm going to realize that 9x is 3x squared and 25 is 5 squared. So based on the last problem, does anybody want to guess how this one's going to factor? Any guesses? Yeah? 3x minus 5 and 3x plus 5. Perfect. The 3x comes from here. The 5 comes from there. And we need a plus 5 and a minus 5. That's why we get a 0 there. So we can use this pattern to help us out, kind of a shortcut here. Now if we don't see that, that's fine. We can always factor this like we've done before. This is A, that's B, that's C. A times C is 9 times 25, which is 225. And 225 is 15 squared. So when I set up my cross, we need to multiply to 225, add to 0. So that's going to have to be a plus and a minus. I have to add and subtract to get a 0. Well, the two numbers that multiply to 225 and add to 0 are 15 and 15. And then we set up our box. So we have 9x squared minus 25. Our factors here. Now we get our greatest common factors. The biggest number that goes into both 15 and 25 is 5. Biggest number that goes into both 9 and 15, 3. Smallest x here is x. Well, we know 9 and 15, that's a 3. Smallest x is x. We figured out this number that goes into both 15 and 25 is 5. And since this is negative, we have a negative there. And it gets us 3x plus 5 times 3x minus 5. And if we use slip and slide, if we like to use slip and slide, I'll do that one. 9x squared plus 0x minus 25. I'm going to slip the 9 over there and multiply. So we get x squared plus 0x minus 225. And this should be a minus here, because this is minus. This should be a minus. And we figured out our numbers here are positive and negative 15, x plus 15, x minus 15. But we multiplied by 9, so we need to divide by 9. And 3 goes into both 9 and 15, so we get 5/3, x minus 5/3 when we reduce that fraction. And now we slide 3 over. 3x plus 5, 3x minus 5. All right, questions there? I want to look at one more. We're not going to go through the whole process. I just want to set it up so we remember the start of this, this problem. Let's say we want to factor 12x to the third minus 3. So we should always start by looking for a greatest common factor. Is there a number that goes into both 12 and 3? 3. So I need to factor that out. I need to pull that out front. 3 times 4x to the third minus 1. Sorry, I don't want this to be a third. I want this to be squared. I was thinking about tomorrow's lesson. All right, let's try to be smart about this. 4x squared is 2x squared. And 1 is 1 squared. So let's try to do this factoring using the pattern that we saw in the last two. Anybody guess what is going to go in our parentheses here based on what we've got here? Yeah, you've got it. Emily, what did you say? 2x minus 1 times plus 1. There we go. This is exactly right. We could go through our normal factoring process. I just wanted to set this one up to remind us that if we have a greatest common factor, that needs to be out front of then the regular factoring that we do. Our book, they consider this a special case. They call this, when we have a square and note b equals 0, they call this the difference of squares. The difference meaning they're subtracted. This is a square and this is a square. So difference of squares, you can use this pattern to help you factor them. You do not have to. You can always factor them the way we normally do, by writing this as 4x squared plus 0x minus 1, and going through the normal process that we've been working on for the last few days. All right, questions? Okay, stop this.